Hello. It is time. All right. So, I was trying to do right in here an anti-gravity effect proportional to each leg, depending on how much it actually needs that. So I think I've got the method for it. Also, I mean, I don't know. Is this correct? Should I be using the result of a cosine, or should I convert it into the angle and then do that angle over some value? Here's my thinking. Here's what I think. There. All right, so the unit circle. 45 degrees, I can see from here how I would produce 1/2, right? Because I've square root 2 over 2 and square root 2 over 2. If I were to do, I suppose it would be the y component over the sum of the two. So in this case, it'd be like 1/2 over square root 3 over 2 plus 1/2. Here it would be square root 2 over 2 over square root 2 over 2 plus square root 2 over 2. That'd be 1/2. Here would be square root 3 over 2 over the total, right? And then at 1, or cosine of 0, it would be 1 over 1. Here would be 0 over 1, right? So what does that come out to be? What would that come out to be? If I took the sine of x over the sine of x plus cosine of x. I need to see pi. So pi over 4. .5. And the pi over 2 is 1. I mean, this is really close to a straight line, but it's also not a straight line. What is this? What? How do I make this hit 1 at pi over 2? Am I dumb? What? Oh, this is the y slope. Oh, am I looking for 2 over pi? Yeah, okay. What does this mean? I don't know. I think I'm just meant to use a linear equation. I think I'm just meant to use a linear equation. I feel like it's just gonna be linear. I'm trying to think of what I could possibly look up to see, because it does matter that I'm right. I feel like these, if it's actually something like this, or if it is just straight up the cosine, I guess in this case it'd be like the sine. Right, these are all very different. And this would matter. If I was wrong, this would matter. So how do I know? Because the pink line here is what I get normally. The orange line is what I think I need. And then I came up with this blue line as a way to sort of just match the green line at least halfway, or the orange line halfway. But these differences matter, I think. Like, this difference means on that slope, it's gonna drag slightly down the wall over time. It'd be really obvious with this one, if it was wrong. Or it'd be floating up. It'd be floating up too much. Okay, I think it's linear. I just have a feeling it's linear. I am using that with like slope angles. So as you go up a slope, how do I, switch between maximum, how do I compute the real slope, right? If you're like on a 80-degree surface and you're walking that way, your slope is effectively 0, sort of. Not totally 0, I would have like slip. So on very steep surfaces like that, you would still slide off no matter what. But at least in that case, your speed wouldn't be affected. And as you start going down the slope, you gain speed as you turn up the slope, you lose speed. For that, I use the sines and cosines. I use the dot products. But for this one, it's specifically asking the question, how much of the spring's force is already working against gravity, such that I don't have to add some additional gravity correction. In my case, it would be like the sine. At a 90-degree angle, I need 100% of the anti-gravity. But then here's the problem. At 45 degrees, this one gives a value much greater than a half. To my mind, it should be linear. It should just be purely linear. Okay, I'm just going with that. I'm going to say it's that. I'm going to say it's purely linear. The value I put in to this function is purely linear, and I don't even need total work. It's just going to be... I guess I can go up and drop out total work. Except determined I don't need it. And then I'll just check this one is still the same. Yeah, okay. I will say if I could work with is the sine and cosine always just like... Let me check this. I can't remember. It's not, because they meet right there. So if I were to do 1 minus cosine x, yeah, I can't like shift it, I guess is what I'm trying to say. I can invert it. But yeah, they have different slopes. Here's like a linear linear slope, and this is a constant slope, so there's no transformation I could apply to just this without going in and being like, you know, pi minus x or something. Oh, that's interesting. That. It needs to be pi over 2. Yeah. Okay. Wow. Oh, man. I feel about the same as I did yesterday, to be honest. I feel like tired. Okay. All right, here's what I'm thinking. I think I'm gonna get anti-gravity, and then I'm probably gonna play a game. I'm just feeling dang, like my eyes are heavy. I slept well. I did. I slept very, very well. I went to bed at a good time, and I woke up at a good time. Okay. So each leg, I want each leg to be calculating this value. And what it will be is taking the dot with that, the absolute value, and then I take I will be taking the a cosine of that to get the angle. And then I want, so when these are aligned, this reading is 1, right? When these are aligned, the reading is 1. So I want to, actually I don't want to do 1 minus. So I may be looking for a sine. Okay, let me... This is always weird to look at. So this is what cosine gives me. When there's no angle between the two, it is 1. When there's 90 degrees between the two, it is 0. Okay. So... Goes cheese. Alright, so the cosine inverse. So 0 degrees. And then pi degrees, right? But this would actually stop at pi over 2. Wherever pi over 2 is. Here. It stops here. Right? So I have this nice linear line. So at 0 degrees, I think it would just be... I think this is what I'm looking for, right? Yeah. No, hang on. Oh yeah, I think I just want this over pi over 2. So now when the angle between the two is 0, it's 0. When the angle between the two is pi, it's 1. Okay, that's what I'm looking for. So I need the a cosine, the absolute value. Then I do this times pi over 2, which is, I guess, the same as doing times pi times 0.5. Right? No. Division is the same as multiplying by the inverse. Right? So this should be the same as doing... Why can't I copy? Okay, whatever. Oh, it's 2 over pi. That's right. Not times... Yeah, okay. Yeah, do that. Okay. So I have my 1 minus, essentially. So this now becomes instead just legs. Because I was pretending that I'd be plugging in the cosines, so 0 would mean it's the cosine of 0, but the other way around in this case it'd be 1. Okay. So now I have that value. And what I will do is I will apply the impulse here, and then I check not do a check. I'll just do this, right? I just do, the work is going to be that value divided by the larger value between the number of grounded legs and half the legs, or some percentage of legs. I have this leg mass ratio, which I am using. So how many legs must be grounded? The larger value, is that right? Yeah, okay. The effective legs is the legs size. And this is not equal to 1, then effective legs will be instead the larger value between grounded leg count and yeah, times the body leg mass ratio. Okay. So then here I say I get, well, I already have it, so I will do ooh. What am I thinking of? Can I add this on to total force? No, I don't think so. It's getting kind of warm. I mean, I think what I do is I just do, whoa. Linear velocity, I will add, I guess I only need to do this if this is non-zero, so if not, 0 prox leg, ground absolute gravity. If this is about 1, then I'm going to treat it as 1, so I'll just add the maximum amount, then I won't multiply it by this value. Subtracting times 1 over effective legs. And can I already, I think I can just inverse this immediately. Yeah, let's do that. And yeah, if it's not approximate equal to 1, okay. I can just multiply by that. And this should be stepped. What's the problem? Oh. Okay. Okay. So, in theory, this should work. This should be the anti-gravity. Fully done. It looks like it's just going. Am I missing? Got it. What's weird is that it's turning really well now. I don't know why it's doing that. It used to be getting like super stuck with turning. But I guess I just have it centered really well is probably what's going on. So it's right. Nice. I mean, that's, should just be anti-gravity working. I mean, to me, that means it's working, right? Though... it does look like it's falling. Kind of. Two legs are off the ground right now. It's got only... well, three legs are off the ground right now. It's got only 3 legs. I mean, it doesn't really look like it's falling. But maybe it is. I don't know. It's definitely really close. Can I send you there, hopefully? What do you think about that? It really looks like it's falling. Yeah, it looks like it's falling. I thought it would be linear. Yeah, it's slowly falling down. Huh. Okay. So... I'll try this. It just falls over sometimes. Slightly upside down, I think, would be most obvious, probably. Because then it will actually like detach. I really need like a free cam or something. Okay, let me try this. Let me go and program in something so I can fly around and really look closely at this thing. Wait a second, isn't gravity usually added before any spring forces? No, I don't think so. I think it's probably right to do it this way. Well, I don't know. Actually, yeah, I feel like I should be calculating forces acting against it. Nah, there's like I think I can do damping first. If I have any damping, I can at least do damping. Alright, let me go see. Well, I think I actually have it. Oh, launcher's already open. Yeah, it's like this. Linear velocity subtract linear velocity times total linear damp times step. Okay. Okay, so my idea here is that I will put some action for debug. That would be an action here. I guess I can call it no clip. Debug context. This is probably actually a first-person action. Well, that's not necessarily. I don't know where I should put it. I guess it'll just be global. It should probably just always be there. Always be available. So I'm thinking this is probably I'll say F. That's my F key. And pressed. Well, I don't think I need pressed. Yeah, I don't think this one actually needs pressed. So I'm not doing anything like that. Quartered action is fine. Okay. And then I guess for layer script, I can take in this action. So if this is pressed, I guess I need to know if I'm in no clip mode. Oh, no, yeah, I do want it to be pressed. That's like the single time press is what that means. Yep. If free camo, then I want to disable my collider. Hey, Yulia. Is it just these? I'd like to enable, disable. Yeah, okay. I also need to somehow disable my spring. Recam mode. Let me put this up here. No. That makes sense. There. So character controller should not do incline. if this should be a force ground movement thing only. How's everything? Going well. I'm warm. I think I'm getting gravity working, and I'm just trying to... I'm setting up like a free cam so I can fly around and look very closely at the robot. 3-stream streak. Nice. I don't know who it was. I didn't realize until after I ended the stream. And I kind of feel bad. Someone did like a 25... They didn't do any stream streaks beforehand. And they did like a 25 streak. I just didn't even read the number. But you just reminded me of that. I mean, actually, I guess I can look at who it was. I can scroll down. It's out of the history. So it's actually I can't see anymore. Could I do... Maybe we can turn everything off and just do that one? Nope. I think it was 25. It was a big number. And I really, I was sad that I didn't actually read the number. Because they had never done one before, and I just assumed it was a small one. Like the 3 one. Can you see my one? I cannot. I can't scroll. It's the last yeah, it saved notifications up to a month ago. So that was over a month ago. I think it was 25, whatever the increments are. There's like increments, right? Like you can't do it every single day. You have to wait till like certain values. But it was definitely over 10. Okay. It was 30 last time. I don't remember. Where am I at? What am I doing? Doing that, I'm doing that. I move this inside of here, so this is only for force ground movement. Also, yeah, I feel like a lot of the stuff is actually probably supposed to go inside of here. Maybe not. Maybe I just keep it simpler and I just leave. I'll leave all this out. How's Iridiant? He's doing alright. Should work here to bring some food. Alright. This is a deceleration relative to the total per second. So if I say 1, then over a second I would lose all my linear velocity. I'll say 1. I'll just turn this off when I enter FreeCam. Actually, I'll just turn off crouch. I won't turn off walk. Yeah, I'll move this down. What is this? This is weird. Why is this here? This doesn't seem right. Oh, this it's the window thing. When you press the button, it turns it on and says it's ongoing. So while it's triggered means the window means it closes, it runs as trick. Wait, what? Hang on. I need to check that. If it's 0, return triggered, otherwise I return ongoing. I can't remember. If it is triggered. Because what I do here is I 0 this. Oh no, I get it. I get it. So I'm always reading every frame here, right? So I get the moment that I press the button. And then handle input comes in here and says, is completed means the window is expired, or I've released the button. If either of those two things happen, then I set it back to 0. Which also means if like I've released the button on this frame, then it will set it to 0 before I jump. But yeah, okay, that's fine. Yeah, so this is a little bit weird, what I mean to do here. I kind of want a different context to enable. Where, jump and stuff is, jump and crouch are replaced with up and down. But due to the buttons, due to the like modifiers or triggers that I've set up for it, it changes how they behave. So this means I only get like a quarter second and I get to hold it down. crouch is a toggle, so pressing it once just means I would go down like a little bit and then I would stop. So yeah, I think I kind of need a new context. I could put it in first person. It would just be, maybe that's fine. I'll call it fly. Well, I'll call it free context. Here's what I'll do. I'll duplicate this so I can. Okay. No. No. Clear. Okay. I want to leave the other ones in there. I'm just going to like ignore the inputs, essentially. So I'll still bring in jump, and I'll bring in crouch. I think I'll also allow U and E. That's Q and E on my keyboard. And then that's it. I just leave it like that. So they just trigger forever. Okay. So back here, I will do like that. Okay. Got enable mapping. Yeah. Okay. And I believe it operates like stack. So as long as I've enabled this one after, it should lower numbers have higher priority. I guess I give it a lower number. Yeah, I'll leave up and down relative to the facing direction as well. Okay. You didn't wake up, a live internet theory is real. I can't wait to see what you've sent. I cannot wait. I don't know what this is. Why does the thumbnail look like that? 1 hour of silence occasionally broken up by a Walta. Okay. Why is this 10 how is this 1080p? Yeah, this zombie's doing that Gangnam Style. That's great. That's awesome. Thanks. That made me laugh. $1080p and it's like obviously 360p. That's great. Shouldn't have premium gold edition. Now I understand why the comment said I didn't realize I had YouTube Premium, because you have enhanced bitrate. The bitrate still looks so bad. Will this work? Does this work? I have an issue with the spring. I turn off gravity, but I still have an issue where the spring is gonna do stuff, and I don't know how to turn the spring off. I guess what I could do is I could probably go into Springcast and say like enable it, disable it. Wait a second, I just realized something. If I just always read is on floor as being false, then it doesn't do any of that stuff. It won't do any of that. So what I could say is I could turn off the spring and it will act as though I'm off the ground all the time. Yeah, I'll do that. I can actually just turn off the spring. Very cool. That's all I have to do there. Okay, I already forgot the button, by the way. Yeah, you're just silly. Reload. Okay, you gotta stop. You gotta stop. What are you doing? It's right there. It exists. What are you doing? I'm gonna scream. How can I make this not happen? How can I make that stupid stuff not happen? Because look, it says null, which means it has no override. Except it's a resource, in which null is a valid override. Alright, what button did I say did I make it? Control F? Goodbye. Okay, the buttons aren't working. Why not? Why are they not working? Turn on the debug. Turn on the debug. The debug? Really? Huh. I'm assuming if I were to do like add a canvas layer, I think, then I get like, that would be, it's just called canvas something. Yeah, right. Uh, weird. Okay, but I think I just do that. And then I'll just do like... Yeah. Then I add guy debugger. And that's all I should have to do. And then I can see a lot of information. Yeah. Jump triggered is true, but it does not care. Crouch is triggered. Okay, so why does it not care? Why do you not care? Do I not actually turn on free cam mode? Did I forget to do that? I mean, the actions are triggered. I don't know, this is odd. I think I'm doing it right. Yeah, interesting. Huh. It's weird, it's saying the action is triggered, and then this one is actually not triggered. I am confused. I can read it here, right? Free cam mode is turned off. Oh, wow. I'm stupid. That's it. I'm stupid. I am stupid. Okay. So I need a better way to work through this. I think I have to do this. Vector 3, 0. And then I add these. I mean, I don't know. Maybe I just say if free cam mode or this. No. This is all really weird. How can I work with this? How can I work with this? Maybe what I say is... Perhaps I just read this in immediately? And then I do some of these other checks so I can add to it. And then I guess here I would say if desired direction length squared is greater than this value, then I will normalize it, and then I do this stuff. Right? Maybe that works. It is very floaty, though. It's very, very floaty. Which should just mean I can go here and make a linear damp higher at 5. Probably even more than that. 10. Why is my movement like that? I'm looking. Is it T camera? Great. Okay. All right, I'm not going to use a linear damp, but I will leave it as a possibility. And instead I'm going to say right in here, if, well, I guess, yeah, I guess I should just probably take it off completely. Yeah, I'll do this. Okay. It's really odd. It's really weird movement, but it's there. I gotta take the dog out. I'll be right back. I am okay with this, even though it sucks. I'm fine with it. I can fly around. I'm back. I think as I walked away, I actually think if I just set this to be something, it'll kind of fix kind of a high value, but not really high. Yeah. Okay. And then I think I probably will put... debug input display. This should be group enable, checkbox only. Do that. And then I say, I guess down here, I guess I can put all my debug here at the bottom. I think first what I'll do is I'll probably just say unique name guide debugger, and I'll grab this. Right there. What's the process mode? Give me the process mode. Process mode. Disabled? It should be always, honestly. This should be set to always. And this should also be set to always. How can I check if it is processing? Oh. It's a Boolean called is processing. Disabled. I guess I can instead just check if it's visible. If it's visible when I do this test. No, I specifically more care if it's processing or not. In fact, I'll say if it's visible or it's processing. I need to do this check. Otherwise, if I have debug enable and I want to debug that, then I do guide process mode will be inherit and make it visible. Okay, so by default, this should just disappear, even though it shows up there. This should disappear and not be enabled. So I press escape and go to scene, remote, world, player, canvas. I should see that this is set to not. Disabled. Yeah, okay, good. Weirdly, it doesn't fade it out. If it was here, it would fade out if I set it to be disabled. But oh well. Okay, so if the debugger is visible or it is processing, I check if I want to turn it off. So if I have innate debug turned off or I have the debugger turned off, then I will hide it and turn it off. Otherwise, if these are both true, then I want to show it and turn it on. And it wasn't already shown or turned on. Though it is, I mean, it should just be shown, I think. Yeah. Okay. And then I will test that I can turn it on. There it is. If only that one's on, it's gone. And then if it's like this, it should also just be gone. Okay. Maybe what I will do an acceleration is already really high. May increase that slightly. I mean, it's just making it a lot slower. Oh, there it goes. Yeah, I definitely need to limit its spring force, because if it's like on the ground, it launches itself up really, really hard. All right, crawler. I think I have the Q and the E backwards. This is twice now that I've tried pressing Q to go down, and I go up instead. So I think I got this backwards. Okay. Yeah, alright. Yeah, Q is definitely down for me. And I can't touch it, right? Yeah, my colliders are disabled. So how do you look right now? It is falling, which isn't good. This could also be a problem with its stepping. But I think up here on the flat spot, it does pretty well. That's not really the flat spot. Oh, wait a second. Why did I do it like that? That was the wrong way to do it. I'm just adding it. I'm supposed to be doing it at this location. So it should be apply impulse. Which needs to be multiplied by mass. So instead what I say is I get this, and then I would say state, apply impulse, times the shared mass at this location. Whoa. Yeah, I'm still gonna leave this on their own lines. Okay. Okay, so this is what I wanted to do, was that. Come up this way. Think about that. It's clearly falling. Oh. Can you figure this out? So my thinking was that this value would be an overcorrection. What I'm doing right now would be an overcorrection. It'd be too much anti-gravity and he would float away. And that's not what I'm seeing. I'm seeing too little anti-gravity and he's sliding. Wait, I wasn't flying just then? Weird. Yeah, I anticipated this being an overcorrection. Especially once you got up to like slightly higher angles. In fact, it seems like it literally can't climb the wall anymore, which doesn't make any sense because it was just doing that. Why won't you climb the wall? Huh? Are you serious? Don't tell me you just straight up cannot climb the wall. Because you were just doing it. I didn't change anything. What are you doing? I literally walked you up the wall. I said, huh, that doesn't seem right. And then I hit restart because I thought the up and down was being weird. I don't like that. And then, I mean, I guess I did change the shared mass. So now they actually apply like force impacts. I think, apply force times state step. Gravity times that, apply impulse, negative gravity times shared mass at the impulse point. I'm sure this will launch it, right? He launches here. At the slightest incline. At the slightest incline, he will launch. Yep, there he goes. Okay. All right. Right, it cannot climb anymore. Interesting. So I changed it to apply impulse and it's unable to climb. Why? I mean, maybe this is meant to just be mass over the leg size. Maybe this is just supposed to be mass. Because the inverse gravity legs already accounts for this. It still slides down. Either one of these strategies, it still slides down. Why? I don't get it. Is the problem the order in which I apply these? Is that the problem? Should I do this prior to the spring? Um, should I be using the white line? I need to make it the white line. Alright, what line of operations would I need? Probably what I do is I would just do sine of this looks like the simplest one, I guess. I would do cosine, a cosine, and then sine. Because cosine would normally give me a value of 1 when they're well aligned, but I would like a value of 0 when they're well aligned. And when this is 0, I want max, right? So maybe I want this. I do the sine of that angle. And then it seems like I just don't even need that other bit. I can just run it through sine. Yeah, because if it was negative, it still comes out being positive. Yeah, right. Is it the same thing? It says it can return a negative value, right? Isn't that what this says? Oh, X will be clamped. Oh, okay. But this is okay, yeah. Let's try that. I see it sliding. Should I do it here? Also, I don't need this value anymore. I do have to know the grounded count before I can do this. Man. I just don't like looping through this so many times. It's really annoying that I have to do that. It seems like I probably have to. It doesn't make sense to me. Because at this point, it is technically applying more gravity than it should have to at this point. Right? This is the line that I'm using right now. It is always more than linear correction. It's always higher. It's always more gravity, anti-gravity than it should need. So why is it wrong? No matter what I've used, it's been too little every time. Okay. Stupid thing. All right, so what have we got? Linear velocity is slightly down, and slightly positive, which is whatever. Am I accounting for it wrong? Do I need to like pull? No, because the springs pull me into the ground. Gravity will push me down. I need to push back on gravity before the springs pull me into the ground. That's what this is doing, right? So it should probably be first. And I do all of it before any of the springs get to act. And this, yeah, this includes includes the proportion that it's accounting for as well. I don't know, maybe what I should say is set desired gravity to 0, and then I apply gravity myself. So I apply the gravity impulse to each of these locations. Maybe that's what I do. I mean, I shouldn't be changing this, right? Like, I don't know. It's... I want to handle gravity myself. But I want to do it at the place that gravity happens as well. I'll do this. Custom pre-moving forces. Okay. Then I need to ignore that. I don't know where to put that? I guess I'll just put it there. No, I want to put it above. Nah, put it there. Okay. Okay. And what I will do is I will say yeah, I'll do this. I'll do this. So hello Namus 2A. So custom gravity. It would be I have this, but I don't think I'm ever going to turn that on, so I can just probably ignore that. Total gravity times desired gravity. Is this language C or C++? Interesting question. This is Python. That's, yeah, okay. It's Python. You're very far off. Thanks for following. That's really, you're pretty far off. It's Jon Snow if he was Python. I don't know what that means. What does that mean? You ruined it. What? How? So I start by removing that, and then what I'm going to do is I'm going to I think what I say is I apply yeah, I think I apply gravity based on this, right? So I compute new gravity. If this is not 1, I multiply by this. And I think I'll do this. This up here. This will be equal to that. subtract gravity because it would have already been added, and then I will add it back using this. The best version of Python. It's GD script, but it's definitely more like Python than C or C++. Okay, so I'm gonna use a metaphor here. Think of what Korean and what Japanese look like. If you don't know either of those two, they both look the same to you, right? But that question hit me as if someone was looking at Korean and asked me if it was Japanese, or the other way around. Was looking at Japanese and asked me if this is Korean. And I'm like, it's not, in my eyes, it's not even close. And it's like surprising that I would be even asked the question. But that's if you don't know either, then it's like, you know, you couldn't tell. But since if you knew what both look like, then you'd be like, what? Okay. So I do this, and now what I'm going to say, in fact, is I'm going to change this from all this A cosine stuff. I should be able to change it. Why does this keep doing that? I should just be able to do that. And I will do absolute value dot with that. Lame example. I think that's the best example I can come up with. I definitely like kind of feel the same way when someone's looking at Korean and say, I don't understand Japanese. It's kind of the same feeling I get. I'm like, it's not Korean. Or it's not Japanese or whatever. Do you know anything about C#? I probably know enough that I could just start writing it. Though I have not ever written C#. But I think I've seen enough of it, and I've written enough Java and C that I could figure it out pretty quickly. Oh no, I have done C#. But it was very little. It was basically just debugging something. So I wasn't actually implementing anything, I was just fixing a bug. Or several bugs. Okay, so I get rid of what I added in gravity. And then I'm going to add it back like this. Okay. Can I make you fall? Okay. I feel like I failed. How? I'm doing the absolute value of the cosine, which means 1. So I get in here and it's 1, and I'm applying that impulse. Weird. All right. I got launched by the balls. Why don't you fall? Why don't you fall? Fall. How did I do this wrong again? Oh! Nope. It's this. So... if this is not approximately 1... Right, yeah, okay. So I'm going through all of the legs no matter what. I'm applying the impulse no matter what. This is, I think, probably not correct. So... it's like the amount of work, right? The inverse gravity. Oh, geez. Okay. So... for each leg, I'm trying to add gravity. Times the mass. Though it's not quite correct, this should probably be... yeah, in this case, it should be... oh, jeez. If the leg is grounded, then I might do something else, right? I'm going to reduce how much gravity I apply when it's grounded. So I think I'm maybe doing like negative? No, I'm reducing the amount of gravity that I apply. So when they are aligned, I get a value of 1. When they're not aligned, I get a value of 0. So that's what I want. This should be... yeah, actually, I just do stay... wait. I multiply it by mass over the number of legs that I have. I guess I can do gravity. Yeah, wait, why am I doing like that? Gravity is this times step times how much each leg will... oh gosh. Will receive? But say that I have... yeah, okay, I get it. I think I get it. So I totally get rid of gravity. Oh wait, no. If the leg should be applying anti-gravity, then the leg just will apply no gravity, right? So... oh wait, but I do have to calculate this every time. Ah! Gravity's already there. What am I doing? Leg gravity. Vector 3 will be equal to gravity times times mass over leg size, right? There's leg gravity. Leg shared gravity, alright? So then now leg gravity. I will start with the leg shared gravity. And then I reduce this value for each leg. Multiplied by that. And then this will just be leg gravity. Alright. Fall over. I mean, I can see it bobbing now, which is good. So that means gravity is applying to the legs correctly. Closer. Alright, good. Now come up here. I'm going to ignore that weird twist and just assume that was leg stuff and not gravity related. Why are you falling? Okay. Let's try the sine. I think it should be linear, probably. It probably is meant to be linear. I think linear just actually makes the most sense. Further. I'm gonna ignore that again, because that's just, I don't know what that is. No, 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 no. Why? And it can't even climb anymore. Like, really? What? It can't even climb anymore. Do I really have to say, like, that? I don't know. It's not enough. How is it not enough? I get rid of it because I've added some, so then I get rid of it. A crawler character's desired gravity is always 1. Should just be 1. Right? Gravity times mass over leg's size. Okay. Then I go through each leg. If the leg is grounded, and then I say if this value is not approximately 1, then I will multiply it. I mean, am I thinking of this right? When they're aligned, I read out 0. When they are at 90 degrees, I read out 0, right? I meant to say 1 and 0, by the way. So if I flip that to be a sine, then I say, or I don't know, should it actually just be 1 minus the cosine of x? Should it be like that? No, it shouldn't be, because I'm multiplying gravity. So when they are aligned, I want full gravity. When they're not aligned, I want no gravity. Oh yeah, this is kind of wrong, right? Should it be like 1 minus? Yeah, let me try 1 minus. So when they are aligned, I get full gravity. When they're not aligned, I get... Let me try that. Let me try 1 minus the sine. Because this is reduction now. That was my mistake. If I can find it. Oh, and this should be ground to absolute gravity. If we are grounded, this is like if we weren't grounded. So ground absolute gravity is 1. Yeah, ground absolute gravity I need to make sure stays as 1 as often as possible. Just stay as 1. I only want to reduce it in some cases. Alright, alright. Okay. Alright, now this should be working for sure. He can climb up, but then... It's really stable here. It is pretty stable. It's probably not... The thing is, this is still like an overcorrection, right? I'm seeing it. I'm seeing it. So... They can reduce gravity more than that. I don't know. Let me think about this. Okay, hang on. Let me, I think, investigate this. So this is gravity effect, is what I'm looking at here. So if I say 0, I want no gravity. If I say 0.5, I want half gravity. But I'm giving every leg at the same time. What? Okay. So I'm just doing this over the length of legs. Okay. So this is how much I want gravity to affect it, right? So yeah, it should just be that over the length of legs, right? Is that what I'm doing? Leg gravity is like shared gravity. Gravity times mass over leg size. Absolutely. Yeah, I don't get it. I guess it's actually the case where if one of my legs is not grounded, then I end up with that leg just applying full gravity, but the other legs can't counteract that. So maybe this is meant to be mass over... But then if... Because... What? I think probably what I should do is get the legs fixed so that the legs will reset correctly even at low speeds. Because right now they're just like stuck floating. That's probably what I need to do before I can really work at this, because what should happen is that if one of the legs, let's say I have 3 legs, 2 of them should be enough to fully counteract gravity. So what happens? One leg, if it's not grounded, should essentially be feeling gravity on that side, but then the other 2 legs will push up harder. So maybe overall the body might settle, you know, it might slump down a little bit or something. The leg that's not attached might end up at a lower point, but then eventually it should be steady, right? There's also the fact that the body should be wanting to apply some torque to itself. So if that was happening, the springs will handle like the tilt and roll torque, but then the body itself does its own yaw rotation. So even if it is slumping down, the body's going to rotate it back against that to face some target direction. But only if the legs can settle. I think right now what I'm seeing is the legs can't settle correctly, so it's just always at this really small falling speed. But I mean, even then, if one of the legs is off the ground, the legs can account for that. They can make up for that. Man, I don't know. I do have inverse gravity legs, which gives me... I mean, I'm not even sure why it's telling me it's not unused. It's technically unused. I only write to it, I never read from it. It probably thinks it's used because I technically passed it to a function here, so that's probably what's going on. Larger value between the grounded leg count and this. So if I have 4 grounded legs and this is 1 over 4. If I had 3, this would be 1 over 3. If I had 2, this would be 1 over 3. If I had 6, this would be 1 over 6. So maybe this is meant to be... If the leg is grounded, I get shared... No. I would get gravity times... I don't know. Let's just do this. Just like making random guesses, honestly. This thing spins so much, it's really weird. It seems to get sped up after the leg's detached. Yeah, I'm seeing a leg detach and then the whole body is moving, and that just shouldn't be happening. I mean, okay. What's happening here is that another leg is applying gravity, and this one should be applying not necessarily this, but it should be applying extra anti-gravity on top of that. If all my legs are grounded, they're all applying 0, or they're all applying whatever value for gravity. If any of my legs are off the ground, all of the other legs should then apply some actual anti-gravity to account for that leg that's off the ground. So right. What are you saying that this is? What? Not previously initialized. Okay. Hit shift tab and it like auto-filled. I guess I just missed a shift. So I'm just thinking too much. I don't like it. It's making me. It's confusing me. I'm confusing myself. Okay. All right. I'm gonna take a short break, and I'll see how I feel when I come back. So I'll be back. I'm back. All right. What is like save all? Save everything, please? Okay. I am gonna work that out in the background. What am I looking for? Wait. Alright. What I want to watch is not this actually. I think I can probably I can probably was this like 4 months ago? It was on their channel, it was like 4 months ago. They have episode teasers? Yeah, okay. Oh, man. I'm really confused. Wait, are you serious? Oh no, these are all like 30 minutes. Okay. I thought for some reason that these two were like an hour long, and then the one that's actually technical is like 20 minutes. It's like, okay. Alright. Okay, I'm gonna assume it's this one because the thumbnail has the robot. So I'm gonna watch this. And
Hello and welcome to the final
hopefully laugh a little bit at them.
on the development of Arc Raiders. In the previous 2 episodes, we detailed how Arc Raiders changed from the fast-paced co-op giant machine hunting game to a more intimate and tactical PvPvE extraction shooter. But the dream of taking down large, intelligent machines never died. In fact, it may be the defining technology pillar of this entire project. I say maybe because for years Embark has been struggling to wrestle results out of this new tech. You see, early in Arc Raiders development, the team at Embark decided to make a gamble on an emerging technology, to make machines that would seem to move with intelligence. It's not AI in either the traditional gaming sense or in the new generative sense, but rather adopting breakthrough machine learning research in the field of real-world robotics. A way to allow the machines in this game, both large and small, to move realistically, allowing them to cross complex terrain, to react, fall, and stumble when under enemy fire, to walk, run, and jump even when one of their limbs has been blown off. I spend a lot of time talking to a lot of smart people to understand how exactly this technology works, the groundbreaking new game design language it opens up, and frankly how difficult it is to get any of this to work effectively. But before we get to any of that, let's first quickly remind ourselves about
This could be a crazy sponsor segment, but they're not doing that. Or a sponsor segue. So what I was saying before is that this is bad because they control the environment. They're not putting these robots in the real world. They know exactly what these robots are going to encounter, everything. It's just like, yeah, that would be cool and also really difficult and unnecessary. And they did anyway. I cannot believe that they're gonna do this for anything other than like the multi-leg crawlers. And the problem with it is that it's not generic. You don't get a super algorithm that just can handle any number of segmented legs, any number of legs in any orientation. Every single robot design you make, even a centimeter change to any of its legs, removing a leg, you have to train it every single time.
the machines that populate this world.
So if you want it to be able to still walk with 3 or with 5 of its 6 legs, you got to train it with each one of those legs missing until it can adapt to it. It's just so inefficient.
instruments of the game's antagonist, Ark. We filmed these interviews in 2024, around a year before the game's release date, so much of what the interviewees are talking about has itself changed in the 12 months since. What work is left to do, and how is Ark Raiders likely to evolve before it's released?
I feel like at best you just get something that looks from they don't the thing is they're not showing them doing anything interesting, which is weird. Every clip of the robots, they have all of their legs and they're walking slowly over relatively non-trivial ground. And it looks like every time they attack, they just ragdoll on you is what it looks like. They look like they're not very intelligent.
Internally, we kind of broadly define the enemies into aerial enemies and ground enemies, just because of how we have to build them and how they behave tends to most cleanly fall into those two categories. And then within those categories, it tends to be like lighter enemies, fodder style enemies that, if ignored, they'll hurt you, but aren't a tremendous deal to take down, up to much heavier enemies that are a significant threat to you and take a lot of effort. So on the low end of our aerial enemies, we have the Wasp, which is just a pretty light aerial drone that is somewhat
like, I mean,
in its movement and has a light
even that
machine
segment,
gun, are a
like,
significant threat to you. Enemies, fodder style enemies that,
I don't buy it.
if ignored,
It looks
hurt you,
dumb.
but aren't a tremendous deal
It
to
does
take
actually
down,
look dumb.
up to much heavier enemies that are.
It's just walking. I don't see any indication as being knocked around by something. It's just walking and it like trips.
Significant threat to you and take a lot of effort. So on the low end of our aerial enemies,
Like, what is it doing there with its
we
legs?
have the Wasp,
It looks like it can barely walk
which
there.
is just a pretty light aerial drone that is somewhat erratic in its movement and has a light machine gun, and it will pepper you with bullets. And then its sort of big brother version is the Hornet, which has significant armor plating, which necessitates the player to either use maybe a type of grenade to take it out. They need to flank around behind it and take out its thrusters, which are unarmored. So the Rocketeer is an aerial enemy, and it's kind of what it sounds like. It's just a very large aerial drone, fairly heavily armored, and will kind of saturate areas of threat with rockets from a distance, so it kind of flushes players out.
If you want to just shoot for the center, maybe it takes a few more hits, but it's easier to hit, and each hit will kind of knock it back. So if it was getting ready to shoot at you, you can kind of throw its aim off just by knocking it a little bit. And that has always been the case. So there's always this concept of like a popcorn enemy, where it's like you get a lot of them and they don't take much damage to destroy, but it's like pop, pop, pop. It feels very satisfying.
And then our ground enemies are primarily our answer to interior spaces, which again in Pio 1 weren't really a factor. It was a building you would run through at 50 kilometers an hour because our move speed was so high then it didn't matter. Whereas now you are slowed down and are interacting with containers, and we need a way to present threats to players in interior spaces. So we've gone through a lot of types in that area, but today we have what we just charmingly call the fireball, which is basically this metallic sphere that can roll quite easily in interiors, and then it opens up and shoots fire at you.
The initial need was to have an enemy that was really fast and that could really catch up to players, right? Like, we needed something that would be able to traverse our world in the game. It's beautiful, but it has quite a lot of complex geometry, and there's all of this verticality and all of these slopes, and it's quite difficult for many ground moving enemies to navigate. So we were like, okay, we need something that can be on the ground, but that can really go after players when they're like swinging around and jumping and bolting and going with their snap hooks and stuff. And then we were like, oh, wait a second. A ball.
Yeah. You don't need legs, you don't need wheels, you don't need tracks, just roll.
It just goes to where it needs to be, right?
And we have another one called the Tick, which is kind of a creepy little spider-ish robot, and it can cling to walls and like hop off of them, and it will summon other enemies if you get close to them. So the and it will summon other enemies.
Really? It is sideways halfway in the wall. Or no, it's not sideways. It's like normal orientation halfway into the wall.
You get close.
So the loot from the AI are the ones that
Sorry.
are nicer. So like you find the core from one of the enemies, it's a grenade. There's an enemy that call other enemies. The piece of it does the same, so you can trap another player. Just like throw the thing, and enemies will drop on them. So like we are trying to make you use of the loot that way. To make players just like throw the thing that call other enemies. The piece of it does the
All right. Frame by frame. It's got 6 legs. Get enhanced bitrate. 4K. Do I cover it? I don't. I don't think I do. Okay, I don't think I can handle 4K. Can we not, like, be weirdly laggy?
trap another player.
Can we just load? Hello? Am I, like, killing my computer doing this? I don't understand. Oh my god. What the fuck are those legs doing? Dude. I thought they looked weird. Assuming the creature is facing, the robot is facing the camera, its front left leg goes from this orientation to literally completely upside down in a single frame. That's kind of crazy. It's crazy work right there. And then just classic YouTube, I can't load a single individual frame of this video. I'm permanently loading. I mean, it's not moving with his legs. I'm pretty sure it's just like the other thing. It just picks a direction along the ground and glides, and then its legs just do its best to make it look like it's animated. So it's not this thing definitely doesn't have any. There's no leg physics. Definitely not. I would imagine this thing would probably instantly flip over and fly off into space if its legs were moving like that. So this is just purely. I mean, I think in my case, if I do a smaller ones, I might just do the same thing. But that's just some crazy. I would just animate it, honestly. I would just animate the legs. Have like a forward. Just do it like normal 2-leg character walks. You have the forward walk, you have the backward walk, you have the strafes, and then you just interpolate animation between those 4 states, depending on which way it's moving and which way it's facing. I don't know what they did here.
And enemies will drop on them. Like we are trying to make you use of the loot that way.
The first step on the journey to realistic machines is creating a world in which physics are accurate. Most games will animate their characters irrespective of the laws of physics, but if Embark was going to create a world in which intelligent robots could walk around as they saw fit, they had to ensure that laws like mass and gravity were consistent, that the world of Arc Raiders was capable of creating emergent moments between player, machine, and environment.
Our enemies are fully physicalized. All parts, everything, they use physics to an extent that sometimes it's even a challenge. Because if we really want the drone to do a barrel roll, it can't because of their weight and the thrusters. All of that is super realistic in the game, right? So it's not easy to justify it doing a barrel roll. And all the parts of the drones as well can be peeled off.
So is he saying they wanted it to do a barrel roll at some point and they couldn't figure that out? So they scrapped it? It's unfortunate. I feel like if I was programming a warbot, I would say okay, I mean, first of all, you know, profile is important. Profile to whatever it's attacking should be as thin as possible, very difficult to hit. You want it to be probably against the vertical plane, so left. So it'd be like a horizontal line relative to whatever it's attacking. Make that as thin as possible, and then I guess my thinking is like, does it dodge? Does it need to do a barrel roll? Probably not, but it would look cool if it did. The Banshees in Halo, as far as I understand, are like, you know, in a way physically simulated. But when you do certain things like the backflip or the barrel roll in the Banshee, they're not really, I mean, it's like a pre-programmed velocity that it takes on, right? Because it really does spin. You can do you could kill someone by barrel rolling correctly on top of them, right? And the wing of the Banshee would hit them and it would actually hit them and launch them correctly, right? So I'm assuming that's what they did. They just went in there and they said, all right, can I code in some set of velocity instructions to make it do something that looks good? And that's probably just what they did. Maybe for the barrel roll, that's what they did. Or I know that what they have done before is they would record inputs and then replay those inputs. So possibly what they could have done was they might have gotten rid of any limitations. So in the Banshee, if you go up, you're limited to going straight up. If you go left, you're limited to like some amount of tilt. So, or some roll. Maybe what they do is they take those limits off, they record their inputs, and then they forcibly play that back on the Banshee. Whenever they play back some like developer recorded inputs, getting rid of the limitations. So the Banshee can flip upside down. It can rotate fully. It can roll completely upside down. Maybe that's what they do. Or they just went in there and said, yeah, angular velocity plus 20% and then minus 20% to, you know, do the roll and then stop the roll. I feel like that's not that hard to figure out. Now, it would be hard to figure out if your whole input was controlled by a neural network. That might be difficult. Because you don't know what the robot's doing, and you would have to like you have to tell the robot to stop operating, and then while you play like some pre-recorded thing. I don't know, that doesn't seem that hard.
And the drone will actually react to that. If it has one thrusters left, it's going to try to shoot, and that is going to impact its trajectory and all of that.
I think it's a choice between control versus emergence, really. Because, like, if you want to be able to say, like, look at a game like Dark Souls or something, Bloodborne, where they have these enemies that have really specific patterns, and it's like they want the player to learn, okay, after 3 seconds it's going to move to the left, and then it does this move which takes X amount of time, and then something else happens. If you want that kind of control, you cannot use physics.
Because a lot of design philosophies is
Seconds it's going to move to the left, and then it does this move which takes X. Bloodborne, where they have these enemies that have really specific patterns, and it's like they want the player to learn, okay, after 3 seconds it's going to move to the left, and then it does this move which takes X amount of time, and then something else happens. If you want that kind of control, you cannot use physics.
What's your title again? Oh. Well, that's just a lie. You can use physics, 100%. There's nothing stopping you. I just said, pre-recorded inputs. You could literally physically attach yourself as a controller, take off a bunch of limitations, and then like record it in like super slow motion. And just play back the accelerations. Because that's, everything moves via acceleration, right? You increase linear velocities, angular velocities, or you modify them. You could literally program it to say, hey, let's do a strafe and shoot maneuver. Let's accelerate to the left for a half second, stop, shoot, accelerate to the right for a second, stop and shoot. Like, you can. I don't know why that's not true. Technical artist.
Really, because like if you want to be able to.
And then she's nodding her head like, what? Yeah, that's right. You can't use fit. Yes, you can. You can.
Say,
you can.
like, look,
You can do whatever you want. It's a computer. It's software. You can literally do whatever you want. And yes, you can. You can say, yes, I want a fully physical enemy or character that only moves via changes in velocity. And I want to program some sort of pattern behavior. You can do it. I don't know why they're saying they can't. You can.
look at a game like Dark Souls or something, Bloodborne, where they have these enemies that have.
In fact, I believe that's exactly how all the flying vehicles, in fact, probably all vehicles in Halo work. Those are fully physically simulated objects, and you interact with them by acceleration. The Banshee's trick maneuvers, those are all still physics. It's still a physical object doing that movement. And it's still using accelerations. So that when they collide with something doing that movement, it's kind of a trick. You know, you get close to somebody, you do the backflip, and it's an incredible, huge acceleration instantly, but it keeps you in place. So you can like flick something really hard by doing a backflip next to it in a Banshee. That's not kinematic. That's still physics.
Really specific patterns, and it's like they want the player to learn, okay, after 3 seconds it's going to move to the left, and then it does this move which takes X amount of time, and then something else happens. If you want that kind of control, you cannot use physics.
Because a lot of design philosophies, especially with enemy design, are really difficult to pull off when you have this type of systems, because it's so much about pattern recognition, right? Like you have an enemy moving in a certain way and like, oh, that's the opening for the attack, I can go in. Or you as a player know that like if I do this, I'm gonna get this reaction from it, and that's gonna happen every time. And that's what games like Dark Souls, like Monster Hunter kind of rely upon. And we had this ambition to have boss fights in that same arena of like Dark Souls, Monster Hunter, like having all of that compelling pattern recognition. But then we also realized that, well, if you knock it in a certain way and the slope is a little bit angled and, you know, maybe someone else is standing somewhere else and firing off a grenade, then that is not going to work. You're not going to have the pattern that you thought.
Like if you've got a big enemy flying in the middle of a pack of smaller drones and you throw a grenade and it explodes, and then maybe one of the engines flies off and hits this other one, which then like crashes to the side. You get all of this stuff, kind of these cinematic moments that are really memorable, and that's not something anyone's designed as such. It's just something that's happened naturally, which is really cool, and like we thought it was worth that.
Exactly.
Versus having to struggle with, okay, maybe we don't get to do exactly what we want all the time, but we get these cool, memorable moments that can just occur without anyone having planned them.
So I don't know why they're doing this. Why don't the drones, when they lose an engine, try to crash into you? If I'm programming a warbot, that's what I'm going to do. I'm going to say I want it to do its best to stay in operation, do its best work. And if it ever detects I'm in an unstable position now, I've I believe that I'm accelerating, that I'm like using this engine to balance myself, but I'm not balanced anymore. You know, do a counter, 2 seconds, not balanced. Okay, we're probably severely damaged. Let's just like fly at the target. Fly at the target. Kamikaze, right? What I was seeing in that clip was he would just shoot one of the propellers, and now the robot can never aim correctly, and he just walks away.
Getting physics to work for barrels or grenades is one thing. Getting physics to work for drones with parts that can be blown off is a whole other challenge. But getting physics to work for machines the size of buildings is an entirely different story. This is due to the nature of most game engines and physics simulations. Games are not used to calculating mass at that scale, and having enemies weighing thousands of tons creates challenges in how they move and interact within the world. Because sand in video games isn't sand, it's geometry, texture, and shaders. Because rock and dirt doesn't crumble under the weight of heavy things in most games.
Inside the simulation, there are just numbers at work here. So the weights of things are there. So you set, you know, this leg weighs 6 tons, or, you know, the center of mass of this robot should be 10,000 kilos or something like that. But to get it to support its own weight,
I'm just gonna assume that's like a weird way to say the central body. The center of mass is 6 kilos.
you know, this leg weighs 6 tons, or,
Say this again?
you know, the center of mass of this robot should be 10,000 kilos.
Oh, he said 10,000. Okay. I mixed it up. The center of mass. I mean, just the body. The main body.
Or something like that. But to get it to support its own weight, you have to set values on how much strength each limb has. And when you start dealing with like very, very insane numbers to try and support the thing, you get behaviors which are sort of uncanny. Very, very stiff legs that sort of like have a lot of energy, but they do small little inputs like this against the ground, and you get sort of like rigid bounciness happening. And if you want to dial that down, then you get something that can't support itself and it starts to trip or fall over and this sort of thing. So there's this middle ground which was really hard to find to make it look natural.
I mean, I think you can just, if it's like at least 10 times the mass of a player, it's going to feel like it's 100 or 1,000 times the mass of the player. I'm not sure why it needs to be that high either. Like you're not making solid steel, right? Hopefully it would be mostly empty space with just like really good armor.
But also give it the power to
Very good light armor, like carbon fiber.
actually locomote.
Well, maybe that's not correct actually. I'm not entirely sure.
It is a classic game issue that when you have physics, they are not
If carbon fiber
penetrating
works as
each other,
armor,
right?
but
You have things and it's resting on top of something. You don't get it buried deep beneath, right? And if we're talking about these big bosses, they would bury themselves into concrete or anything, right? Not just sand. But we can't really do that in games without a lot of smoke and mirrors.
Yeah, it really breaks the illusion when you want to see like an at foot kind of like come towards Luke's speeder and go, and that doesn't happen. What happens is it kind of goes like this, and you're kind of like, huh, I thought this thing was supposed to be huge and big, right? It just doesn't sell it.
Early in the development of Arc Raiders, the team at Embark decided to establish a team to explore the possibility of using groundbreaking research in the field of robotics to enable the enemies to locomote independently of any preset animations. Decision-making would be made using game logic, but how a machine got from A to B would be decided by a brain, generated using machine learning.
You know those Boston Dynamics videos where they try and teach a bipedal robot how to jump up on a box? That's kind of like what Arc Raiders is trying to do, but
also a lot of Boston Dynamics is not just throwing the ragdoll in the sim and just waiting for it to figure it out. A lot of training is actually the person sitting there using the controller, making the robot do what they want it to do, and then that's the training data. They take that, they put that in a sim, they do some change, they start with some variations, they say, match this behavior, please. As close as you can. I'm assuming in this case, they're just like, yeah, the first test, it just like flopped around on the ground until it finally figured out it had legs.
Instead, their robots are way bigger and they have way more legs. And crucially, they have to be able to do something that traditional games can't. And that's when you blow off one of those legs, those robots have to be able to adapt.
I think, as I've been told, like their objectives has been much closer to the same objective.
No, they get into machine learning, and the first guy they bring to talk about it is the creative director. And he starts his response by saying, I think what they told me was,
as Boston Dynamics has, rather than game design problems of like literally figuring out how these machines will navigate with their own vision, and like they had to be physically accurate also, where you put the engines and the downwash and all that has to be accurately, they have to be in accurate locations for it to work. Like what's exciting and what's still exciting is the fact that using this technology for our locomotion system is the losing limbs and still it wants to stand up. It just opens that door to the imagination of what is self-preservance like, and how that speaks back to the players. So to us, that when we saw that, at least, that is an exciting prospect of a new type of experience that players haven't had before, I think. They're literally playing against a machine.
The ML only did, at that point, locomotion. So that was responsible to make it go from point A to B, and that's it. No ML in decision making whatsoever. So it depends a little bit on the model. So some models consume a lot of memory. That is maybe the biggest consideration. And some language models and such consume gigabytes of memory. But this locomotion does not consume that much. So I'd say the expensive part of ML is what we call observations. And that is actually not really ML per se. That is just how the agents get information about the world. So they don't see the world the way a player sees it, of course. They have to, if they want to see a wall, you have to sort of line trace or do a shape cast to see it or detect it. And we need to do a lot of those, maybe thousands, so they get an idea of what kind of environment they are in. At least this is the case for locomotion.
The road to getting this locomotion system to work has been long and difficult, and it involves several different stakeholders from within the team, from animators to technical animators, artists and gameplay engineers. It also required the studio to look outside into the world of research.
I did my PhD in mathematics and thought pure mathematics was a bit too dry, so then I found applications, and the application I found was applying machine learning to biology. So I worked on hereditary diseases like diabetes and Crohn's disease and stuff like that, and tried to identify the target genes that were involved with that through machine learning. Like, it's completely revolutionized the field. I think there's very soon we will see a Nobel Prize to DeepMind, Google DeepMind, for their work on biology applications of machine learning. Like, I'm certain of it, yeah.
Really early on we had, there was a test where even though the gait, so the way it walked, was kind of meh, we threw boxes at it. So we were just throwing these, I think there were 100-kilogram boxes, and it just reacted, and that's when you see, holy shit, there's a magic here. From an animation perspective, I'm used to, okay, how would I break this down into, let's say, a sequence of animations that can, in this case, it would be, we can throw a box at this from any angle, in any direction, in any weight or whatever. And I'm thinking of the animation complexity, so, well, how do I handle arbitrary complexity? Well, then I need to have infinite amount of animations or blending, and that is just a nightmare, which is why you often see things like, if I punch you in the shoulder in a video game, you just do this, cave-in animation, or, the can sequence.
And the funny thing with this tech, I think, is that it's kind of partially ruined animations in other games for me a little bit. So now when I look at other games, I'm like, wait, the center of gravity is off here. Like this doesn't feel right anymore, and it really annoys me.
A connoisseur of animation, I hear.
But everything else they do looks so good. Like when they walk like on a flat ground, like that's an authored animation cycle that looks really good, and animated me like, I want to convey this sense of weight, this sense of menace in this gait, or like this sense of joy or whatever. And we just take whatever the robots give us, and it looks frequently kind of shitty in comparison to these like Disney walks, right?
Yeah.
But on the other hand, when you throw something at it, or when it slips, or when the ground is not even, our robots do the right stuff. And their robots are not robots. They don't do the right stuff. They just like apply some kind of one out of their 20 animations that they have, and it doesn't fit.
The process of training these brains is complicated. It essentially requires somebody to
Please
give
talk
the
about it.
brain certain conditions, have it train using those conditions, and then testing the brain in a machine and seeing what it
Please
does
talk about
right
how you did it.
and what it does wrong.
Please.
An example of a condition could be, if an enemy is far away, run fast to get to them, or if a human enemy is firing at you, attempt to jump over them. The core problem with this work is that once one of the brains is baked, you can't simply tweak its behavior. You have to go back to the original conditions, retrain the entire brain, and then test to see if the new brain works better. And this causes a problem
Exactly.
because the solutions that a human might have can be very different to the solutions these robot brains come up with.
We found some fun at playing against the big ML enemies, right? And the problem was to replicate that fun. It was very difficult because it's not predictable. It's very hard to just say, do this, right? It doesn't. It doesn't follow orders that way. You have to train it and teach it, and sometimes it finds weird ways to get to do things more efficiently, like removing all the legs but 2 from the ground because that's faster for it. But then it looks silly. It doesn't become a menacing enemy that we wanted, right? So we always had that dilemma dealing with ML that is not the predictability part of it.
The damn agent learned that if I just shove my foot into the ground really hard, faster than the server can keep up, I can use the penetration to bounce myself, right?
A typical example was that we give it a cookie when it reaches or when it moves towards a flag, right? Yeah. And when it gets to the flag, we move the flag to a new place, right? At some point in time, we try to train it like the closer it was to the flag, the bigger the reward it got, like the better the cookie, right? And what it learned, of course, was that it runs up to the flag and then stops like with its nose like this close to the damn thing. And it's like, I know if I touch it, it goes away and stuff starts hurting. Like that's much worse. Oh but you're touching something that I think is a huge problem, which is the interaction between game designers and the ML loop. Like that's been really hard. Yeah. For a long time, I felt like the game designers would ask us something, and we think that's.
That is the challenge of it. If you decide to do this, they even said it exactly like that. Apparently, they're putting behaviors into the whole neural network at the same time. So you don't even have a neural network for movement. You just have a neural network for all of its behaviors, apparently, which just sounds crazy to me. I don't know why you do that. Locomotion should purely be make the animation, tell it, try to match this animation, and give it the physical body, and say, all right, you do better if you match how well you match the animation and how high you get. How well you match the animation and how fast you can move. But even then it's like, okay, well, how are you limiting how fast it can move? I think part of it, I think what I saw in one of the clips was they have a velocity reward, which I would think means fast in the direction you want to go, but not any faster than what the designer has said you can move at. So it says you can move 10 meters per second. That's your limit. Don't go faster. So the more it can match that speed, the more the reward it is, more the reward it gets. And then I think they even say they were able to stick parts into the ground with a very high velocity to bounce using deep penetration. That doesn't seem right. I think what you should do is you read in the inputs, you do continuous collision detection. So even if you have an insanely high velocity, you penetrate almost none. You do your best, like for training at least. Use the slowest, most accurate physics simulation for training. Hundreds of ticks per second, right? And then in game you bring it back down to whatever the game level should be, and yeah. I mean, I guess in that case you'd probably want the brain to be ticking at the same physics rate, but then when you're actually simulating it, you probably do like 3 or 4 steps in between, so that it gets feedback that's really, really accurate. So it can't take advantage of mistakes in your physics simulation or bugs. Also the reward thing, where it would get as close to an objective as possible but not collect the objective, because that's how it would maximize rewards. Yeah, I don't know. I feel like you don't train the behavior. You train the locomotion. You tell it, here's your body, here's the direction, go. You don't do all your actual AI behavior stuff is outside of that. So target selection, how it attacks, and when it decides to attack, that should all just be purely programmed as simple as possible, not part of the neural network. That's just crazy.
Possible, let us get back to you. And then 3 months later, we'd be like, yeah, now we have the stomp attack request. And they're like, oh, we worked around that now.
We have the stomp attack.
The team at Embark has tackled these issues with a number of solutions, one being training the brains on actual animation data to help guide their movement, almost like giving the brain a template
that's exactly
to
what they
work
should do.
from. And another has been, instead of baking one brain for each machine, giving them multiple brains that focus on specific tasks. This in particular has proved helpful for both getting the machines to work properly and empowering developers in how they tweak machine behavior.
And I think it's only fairly recently that we've managed to
did
get
they say a month, by the way? The stomp
Instead of-
attack.
With a number of
And then 3 months later, we'd be like, yeah, now
3
we have
months.
the stomp. I think that's possible. Let us, like the game designers would ask us something, and we'd be like, we think that's possible. Let us get back to you. And then 3 months later, we'd be like, yeah, now we have the stomp attack request. And they're like, oh, we worked around that now.
The team at
I hope that
Embark
never
has
actually
tackled
happened.
these
That just
issues
sounds
with
crazy.
a number of solutions.
I'm sure it did,
One
though.
being training the
If
brains
they're
on
doing
actual animation
behavior
data,
training,
focus
what?
on specific
Why?
tasks, empowering
Why?
Fairly recently that we've managed to get the locomotion components we've been working on predictable and diverse enough that they feel like they have building blocks that they can use by themselves, instead of involving us in every single step. They can be like, okay, I know I have the stop behavior, I have the patrol behavior, I have the assault behavior, and I have the melee behavior. Now I can combine these as I want to and create good game design with it.
As you've probably talked about, it's very tricky to get ML to do things with extreme intent, and we've tended to try to ask it to do jobs it's bad at, which is telegraph and attack with precision. So trying to work through those problems where we've got this thing that walks very competently across complex terrain.
I wonder if anyone's done a standing against gravity reward. Because at least, in the real world, if you're about to trip, you feel it very quickly. You're like, I'm falling. You hate the feeling of falling, right? I've heard that supposedly it can wake you up. Like dreaming about falling can cause you to actually wake up. And I'm sure actually falling would also wake you up really quickly, but even dreaming can make you wake up very quickly. Maybe that should be I wonder if anyone's really trained on that, because that seems like that's what nature actually came up with. Nature came up with, all right, let's make this guy walk by making him hate the feeling of being unbalanced or falling. You want to keep your head very stable when you move.
How do we turn that into a game loop that feels
Or I guess just your
satisfying?
entire body, not even just your head, but your whole
Reinforcement
body.
learning, machine learning efforts into locomotion.
Because
something
you
that
also feel that in your
is being
stomach, and
used
that's
today
a
to some
bad
extent.
feeling.
Maybe not to the full extent that we were hoping as we started, and that proved to be
far more difficult than we expected. But we are using it today. It's a part of the game, and it makes the game feel very different than any other game. And that technology will evolve over time. So we were just a little bit too early with it, and didn't maybe have enough resources and knowledge to figure it out at the time.
I think we are getting to a point now where we are getting more and more comfortable with it. So that's why we want to keep it. It's still an ambition. That's why we always have at least one enemy in the game with it. But it is much more complicated. We just did a new prototype of one big enemy like those without machine learning, with procedural animation. And we got the results, as I said, like I can say, just stop there, put the leg here. And do things like that. It was much simpler to produce. But we had a couple animators full-time on it for 6 months. Right. So that's the trade-off there. Yeah.
Arc Raiders is...
What? What? A handful of animators. Sounds weird when you're doing, like, supposedly a physically based thing, but procedural. 6 months sounds crazy. That is crazy. Because I'm so close, and I'm like 2 weeks. It's gonna be less than a month for me. I mean, my hope is that I'll be done with this very, very soon. But really? Full-time 6 months, multiple animators. I mean, my assumption there is that they did literally everything animated, and it's probably a mega monster. Like, they went through and they manually animated what it should look like, with a leg and with one of its legs in several poses, another 2 legs in several positions. I hope they didn't.
Launching into one of the least predictable video game markets ever, where players demand exciting new experiences that they can play with their friends for days, weeks, and months at a time. But this reality hasn't stopped Embark from taking bold risks when it comes to gameplay or technology. In both Arc Raiders and the finals, it's clear to see how much of a thirst the studio has for evolving any given genre, even if it takes years of experimenting. And while I've been embedded in the development of Arc Raiders, it's also been clear to me that they're not scared to tear up lukewarm ideas that don't reach their lofty goals. Time will tell what type of audience Arc Raiders ultimately receives.
They're not afraid. They're not afraid to tear up ideas. Every single large crawler they have was machine learning. I don't think they tore up that idea. I think they just kind of kept going with that idea, and they never gave up on it. And like I said, I mean, if you're trying to put it in the real world and it needs to handle anything, okay, right? It's probably going to get you results very quickly. And if you do your training and you're really focused on like machine learning research, like Boston Dynamics, then you're probably going to, and you're not afraid to take shortcuts. You should always take shortcuts when you can. Like having a guy sit there with the controllers and make the robot do what they want it to do and say, match that, please. And then train on that. I don't know. It's just weird. It's weird. I'll get anti-gravity done and then fix the leg stuff. And then I'm on to destruction. And then I'll have to figure out those behaviors, right? Like, typically you would have a shutdown thing. If you're making a robot that's not meant for war, but you're like, there should be a point at which it says, I give up. Like I'm in such a crazy situation. I can't recover from this anymore. I'm going to go rigid. You know, if you're making a humanoid robot, you know, do the fetal position perhaps, and tuck in your knees, your arms, protect your, you know, valuable parts, and just fall. Let yourself fall and become stable. It looks like they just don't have that. They literally don't have that. They cannot tell. They cannot tell. Because for some reason they coupled locomotion with behavior at the same time. I don't understand that. I don't know why you would do that. We know how to make AI. We know how to make it designed. It's a video game. Like, yeah, it's just weird. You're not fighting a robot. You're fighting a biological robot. Biological imperfect robot. You should be fighting a perfect robot. Take all the shortcuts you need with physics to make it stay balanced if it has, you know, sufficient legs on the ground so it can like perfectly balance itself. If you want to crawl on walls, it looks like in their case they don't have that at all. There's no... They can't stick to the ground. Take the shortcuts. You'll get a better result, and you won't spend 3 months looking for a stomp attack. Six months. I would love to know what they did. What can you do for 6 months to get a prototype of a thing that can walk? Like, how complete was that? Was it like a complete enemy, like untextured? Is it still physically reactive? Is it purely animation driven? Is it procedural? Is it 100% procedural animation? On top of a physics body simulation? I don't know. This thing was definitely the same way. I wish they would talk about what work they were doing. They just talk about how hard it was and all the problems that they had. And they didn't talk about the solutions to the problems. It's just like, and then there's just like the short moments where they do talk about it. They're like, oh, I made the panels explode. I shot a crate at it and it, you know, moved. What else do they say? They experimented with animations as training data. You know, match the animation. Like I feel like it was, they weren't running the right way. Our solution was to use animations. Here's the animation we made. Here's it learning that animation. Before and after, like, it'd be cool. Like I said, it's probably, I mean, this is documentary, but, you know, made by the company. Made by the studio. This is probably the most knowledgeable person ever shown, research lead. He even starts by saying, I was doing biomedical research with like bacteria and genetics or whatever he said. Which I don't know how that relates to locomotion and, you know, machine learning locomotion, but sure. Like, you know, some experience is better than nothing, I guess. You can set up the Python repository or the Python scripts at the very least. Director, like, show me the programmer who showed up and was like, Yeah, I made this happen now. The robot doesn't freak out now when you do this. I fixed the bug where the robot slammed its legs into the ground by running a higher tick server in the background. Like that was a solution or something. I don't know. That's probably the problem with it too. Because of their positions, they know the problems, they don't know the solutions. Oh, you fixed that bug? Cool. Check it off the list. I don't care how you did it. I think it's stupid. I think it's stupid. They have this really, like, Bungie feel, too. I think they're trying to emulate that. They're trying to emulate those videos, but the problem is those guys were actually sitting at their desks working on the game. I think there was a... I'm not sure if it's correct, but, like, hearing how he talked about it, can't believe I forgot his name, but they're doing like a dev reacts to like a speedrunner, or not a speedrun, just like to the game, just someone playing the game. And they were like, yeah, I made that script sequence, I made that sequence. Oh, I messed that one up, right? Those mobs or those enemies are like deactivated because of a bug. And I remember that bug and I just didn't fix it. It's something like that. Or I don't know, like I set up that level, I can't believe it's that broken, you know? That kind of stuff. I swear, these guys are just sitting at their desks and they only remember the problems because that was their job, was to fix the problem. To tell someone else to fix the problem and report the problem to their boss. Or write the problem down as a ticket and assign it to somebody. You cannot animate it.
They like look at a game like Dark Souls or something, Bloodborne, where they have these enemies that have really specific patterns, and it's like they want the player to learn, okay, after 3 seconds it's going to move to the left, and then it does this move which takes X amount of time, and then something else happens. If you want that kind of control, you cannot use physics.
No, you can use physics. Literally take an animation, map it to velocities, boom, it's physics. It will look exactly the same. Compute the acceleration of every bone in your animation for the sequence you want, and replay that acceleration. There will not be a visible difference. The difference will be when it hits something, then, you know, it's gonna get stuck a little bit or whatever will happen. You can. Especially if you haven't tied your behavior to your locomotion. You can tell the thing, travel left 10 meters, travel right 15 meters, now shoot. Or whatever for a big robot. Crazy. It's sad. And they've got people so fooled too. They've got people so fooled. I mean, it could be a fun game, but like as you know, actually understanding software, you would watch this and be like, what the hell? Did they try? Why does everyone have the director designer title? Why is this all directors and designers? Where's anybody who actually made the game? Alright. Well, that's gonna be it for me today. I was thinking about playing a game, but I'm just not going to. I don't want to stream. So I'm thinking still about how to do anti-gravity. There is a negative somewhere in there where like I need to say this leg wants to apply no gravity And then also this leg has a share of anti-gravity. And like, where do I apply that? I'm even thinking that the spring forces probably need to be moved, not to the attachment point, but to the center of the legs, the spring part that I have, the virtual spring part, or just like the midpoint between where the leg is in contact with the ground and then its attachment point. That's probably where I should be applying spring forces and not directly onto the body. Limitations to it, so if it lands and it reads in a maximum compression, it's not going to blast off at incredible speeds. It can only apply like, you know, if gravity's 9.8, it can apply 10 or 11 meters per second of acceleration. Or maybe I just do it on top of gravity, you know, maybe I calculate the leg's feel of gravity, depending on its contact normal. So if it feels 100% of the gravity, then we say, all right, your acceleration is gravity, is that feeling plus 1.5 meters per second. So even if it's on a vertical wall, it still is only applying 1.5 meters of acceleration per second of acceleration. Yeah. I was trying to visualize in my head too. I was thinking about a simple structure of 2 legs on the wall, 1 leg is lifted. What happens? What I would expect to see happen is it'll droop, right? But on that very first thing, what I imagine happening is this one will pull down. You know, you're tugging on this side of the body, and this one will tug up. So what you end up with is this motion. For 1 frame, it'll do this. And then it would do, then it starts, you know, to droop at that point. But that first frame will be like, it'll do this, I think, is what would happen. It would rotate incorrectly. Then I was thinking, okay, well, maybe a leg applies anti-gravity as a friction force. So it reads in we apply gravity to the velocity, and then that leg will go in there and say, all right, what's my velocity? And it says, okay, I want to apply friction against that. And that could keep it in place. But then that's just looking at velocity, that's not looking at gravity, right? So I'd have to look at some idealized knowledge of what gravity was before any accelerations due to motion or whatever, or rotation. I don't know. It's still not complete in my mind, but there's a solution there. I just don't. There's many approaches, and I can't just try them all. Trying them all would take too long. I'd rather just sit there and think about it and pick the one that I'm sure should work and then really go after it. And if it doesn't work, then I think really hard about why it doesn't work and, you know, reapproach it with my best solution. I'm also thinking maybe I don't even do per leg anti-gravity. Maybe I just apply gravity to the whole body, and then I let each leg apply anti-gravity to itself. And then, of course, each leg would also have to make up for any legs that are not grounded, which I think might be what I'm missing. I think that's it. That is what I'm missing. The legs aren't making up for it. So when one leg is applying gravity, the other leg should be applying the opposite force. Maybe that's what it is. Maybe I go through and I calculate how much gravity each leg feels. And then I go through all the grounded legs and I totally negate that by some amount. Like whatever they can negate, you know? Maybe use that linear ramp. where at 50-50, the leg will apply 50 gravity and then apply 50 anti-gravity. Or it'll apply 50 gravity, and then we add up all that total gravity we added, and then we try to negate that by spreading over the grounded legs. So ideally that leg, whatever it added, it would just take off using its own share. It would essentially just be the case where one leg is experiencing, 70% gravity, and then another leg is experiencing full gravity. So now this one has to deal with 30% plus 100% of another leg, right? Maybe that would be it. Yeah, I mean, possibly what I say is that for each ungrounded leg, I would apply gravity at the center of the body and not on that leg point, just at the center of the body. And then I do anti-gravity using like attachment points. At least in that case, it would work. So it would actually pull down and then it would, spin up, right? Or well, I guess the vector would point down, and then the vector would point less down and with a spin. So instead it would be like this, adding those two together. It would be in that step where it drags down and then pulls itself back up and rotates. It would just be calculating the velocities, and then the velocity moves it. Yeah. All right. Okay, well that's it for today. Thanks for watching. I'll be back tomorrow. Goodbye.